Let's revisit some of the identities we have seen thus far, and this is going to help us when we get into proving identities. So let's look at reciprocal identities. We start with cosecant of theta equals 1 over sine theta, secant of theta equals 1 over cosine theta, and cotangent of theta equals 1 over tan theta. Now we can rewrite each one of these identities if we need to, or sometimes it might be helpful. So we can rewrite it as sine theta. So now we're kind of thinking of it from sine theta's perspective, it would be 1 over cosecant of theta. And so we can just follow this pattern. Cosine of theta is just 1 over secant of theta. And this is really just telling us that these functions are reciprocals of each other. Okay, great. Now let's look at quotient identities. Well, we have the main one, tangent of theta equals sine theta over cosine theta, but we can also think about cotan of theta as a quotient because tan theta and cotan theta are reciprocals of each other. So because of that, then I know that I can look at tan theta as just sine over cosine. So cotan has to just be the flipped version of that. So it's going to start with cosine on top, cosine theta over sine theta. All right. The Pythagorean identity, like the main one that we start with, is going to be sine squared theta plus cosine squared theta equals 1. And we're going to use this a lot. We're also going to see this kind of in different ways. So like sometimes I might see this as cosine squared of theta is 1 minus sine squared theta, so just like rearranged. So maybe we'll like notice that like we see something like 1 minus sine squared theta and we go, we want to replace that with cosine squared theta. It might help us. Similarly, we might see sine squared theta and then want to know that that is 1 minus cosine squared theta. Okay, and then we also saw that we can take this sine squared theta, so just this normal version of our Pythagorean identity, and we can use that to create two other Pythagorean identities. So the first one, just by dividing through by sine squared theta, and when we do that, we divide every term by sine squared theta. And what that gives me is this just gets, the first term becomes 1, the second term becomes cosine squared theta over sine squared theta is just, cotangent squared theta, and then 1 over sine squared theta we can write as cosecant squared of theta, okay? And then we can do one more from there, so let's do that. I might just move this over here. So I'm going to write it one more time, and then I'm having sine squared theta plus cosine squared theta equals 1. And now this time I'll divide it by cosine squared theta. So every term gets divided by cosine squared theta. So what do I get? Well, the first term becomes tangent squared theta, second term becomes 1, and the term on the other side is secant squared theta. And so what I really have is kind of my first Pythagorean identity, but then I also get these kind of other two just like for free. And so I want to keep those in mind kind of as we work through the rest of this part. Okay, so even and odd identities. So what's nice about these 6 trig functions that I have is they're either even or odd. So let's start with our even ones. So even the list is a little shorter, I have cosine theta. So cosine of negative theta is just cosine of theta because of our even function definition. And then the same thing happens for its reciprocal. So secant of negative theta is just secant of theta. And then the other 4 are odd functions. So we'll start with sine. Sine of negative theta is negative sine of theta. And so this can be helpful when we get into this because, like if we have this negative angle inside here, I can rewrite it as just like that, like a plane angle with the negative on the outside. So sometimes that comes in handy. Let's see. We have the reciprocal cosecant of negative theta equals negative cosecant of theta, and then tangent. Tangent of negative theta is opposite tan theta. And then cotan. Cotangent of negative theta is negative cotan of theta. And so these identities are going to help us, like I said, when we get into simplifying and proving identities.